Oh, good afternoon, and welcome to Comp 422 and Comp 620. Uh, They were going to talk about cross site request forgery and a little review for the exam that is on Monday. Reminder that there's an assignment out there. You have to do the number-based conversion quiz again. This is second time. The first score still counts as your first score, but now you have to do it one more time, but this time you have to get a score of over 100. In order to get a score of over 100, you're going to have to do something tricky. You're going to have to probably want to either use the debugger in the browser or use a web proxy that stands between the web browser and the website and looks at all the files going, excuse me, all the packets going by and allows you to view them and edit them. I think we showed Burp Sweep last time. Here's the schedule. We are here doing the cross-site order and review. Next Monday is the exam. There'll be no class on the day of the exam. Then there's a class course next week, and a week after the exam is the last day to drop. So, by the way, there's 3 exams in this course. I kind of try to split them apart. But the last day to drop is there. And I want to get the 2 exams in before the last day to drop so that you have a reasonable understanding of how well you're doing in the course. So as long as you're doing pretty well, stay with it. If for some reason you're doing terribly, then you might want to consider dropping. Okay. Cross Site Request Forgery. XSRF or CSRF. When I'm looking at my notes, I realize I use both abbreviations back and forth, but it's one-click attack session writing. Basically, it's using the concept that your system trusts the browser that you have, and if you go to a different site, it will believe the cookies that you have. You can submit unauthorized commands from another website. And yes, cross-site scripting, which we talked about last time, based the trust that you have. Cross-site request forgery exploits the trust that a site has in a user's browser. In the fact that they have the cookie, then it should be okay, which is not always the concept. Okay, so it is, imagine you're on a website and you're looking at one website and you get a cookie that says you're doing that. So then you go to another website in a different tab, in the same browser, different tab, and look at an email or some malicious input or something that goes to another website that causes a request to send to that website you're looking at. Well, you're logged into that website. You have a cookie that says you're logged into that website. So any further communication with that website is going to send that cookie along saying you're logged in. So if you send a cookie saying to do something maybe you didn't want to do, it will think that you're logged in and do that. Here is an example. Okay, we'll assume that Granny's going to transfer money into your account to pay for tuition this semester. Now let's just say your account's 344. So she's logged in, and then in order to transfer it, she'll press the appropriate buttons on the web browser to cause this command to be sent across the web. That's it's HTTP, that's probably HTTPS. acmebank.com, fund transfer, question mark means parameters after that. Account is this, the amount is that. So we're going to transfer funds from her account over to your account. So far, so good. But she's still logged on to her website and she gets an email. She takes a look at that email and decides she wants to look at the pictures because she always likes to look at the pictures. Maybe she has her email set to always show the pictures. Or maybe she just right-clicks at the top and says, display the pictures. Well, inside that email is this image statement. IMG in HTTP says, display an image. The source of the image is acmebank.com fund transfer account 224, amount $50,000. Ooh, that's 50,000, not 5,000. And then 000, it's going to be an invisible dot on the display. So you're not going to see it. So since Granny always views her, this is going to be executed as soon as she opens up the email. It's going to go out to the Acme Bank website, but she's already logged on, so it already believes she can do this. She's already authorized actions. She doesn't have to log in again. She is logged in at this time. And it's going to transfer $50,000, say wrong, 20 zeros there, $50,000 to the attacker's account. That's an example of cross site request forgery, where we are relying on the fact that the browser believes she's logged in and sends another request. The system goes, oh, okay, she wants to do this transfer. She's already logged in. We're going to do the transfer then. Cross-site request forgeries. And again, it's CSRF or XSRF, depending on what abbreviation you want to use for cross. That's these characters. Okay. It involves a site that relies on user identity. It relies on that user having logged into that site, that the web system believes that you are who you have previously claimed you were. And again, exploits the trust in that identity. It somehow tricks the user's browser to sending a request to that site to do something that you had expect. And involves requests that have side effects. In this case, the side effect was moving money. So the site does something. It doesn't just display an image. It's going to go out there and do something. What to do about this? Well, there is the same origin policy. The same origin policy says that JavaScript cannot go out and get information from a server that is not the server that loaded this web page. So if you go out to acme.com and it loads the web page, then the JavaScript in that acme.com web page can go to acme.com to get information, but cannot go anyplace else. It can only go to the same origin. In JavaScript, HTTP, there's a function XML HTTP request. And that's what most JavaScript programs use to go out and get another page, to send information back. Many websites will send files, JSON or XML formatted files, to a website and then receive information back from it and then display it in any way they want to. So if you're going to make an XML HTTP request or a fetch for then it's going to only work if you're going to send it to the same server where you got the page. Again, but this only applies to scripts. Other requests for information, such as images, like the image I just showed, videos, CSS, which are the information about how you should display the page, like cascading style sheets. All right, took a minute there. You have old gray beard, you forget these cascading style sheets, which there's also JavaScript. There's .javascript files. You can get those. Those will download from any site you want to. Many web pages open up by loading a lot of JavaScript from whatever system formatted the web page. If you use a certain web system to generate your web pages, probably the first thing it does is it downloads the standard JavaScript that web formatting system uses. So all those, so images, JavaScript, videos, cascading style sheets, all those can be downloaded from any place. Although the JavaScript in that web page can only go out to the same page. So again, very similar to what I just showed you before, you have an image whose source goes out to some website that you prefer not to go to. And again, in this case, it's showing parameters. You could put a file name here that is unimportant and it encapsulates information from your system. Because if you're going to ask a request for an image from this file, excuse me, from this website, the website will send back whatever it wants to, doesn't matter, but it's got your information. So if you have a nastybab.com website, and you're waiting for this information to come into you, so you get that, and you'll send back whatever picture you think is appropriate to send back to them. And then when the browser gets the image, it will display it as it should. You can change the image in a web page just by changing the source. Remember, in a HTML, you have the document object model. You have an object. In this case, we in this function here, we went out and used the get element by ID to get the input with the user, get element by ID again to get the other. This change this is a image down here. And one of the things you can change in the image is the attributes, in this case, the source, src. So for this, change this image, the one that has the ID, change this that we got over here. We're going to change the source. So the user is going to enter a URL for a picture, and then this program will change it. Well, that's not very interesting in itself, but it shows you that the web pages can do a lot of things. They can change things on your screen, and they can go out and get information from anywhere. When you have a form, a lot of web pages fill in blank, press the submit button, and it sends information off to someplace. Typically, you might think it's going to go to the website where the web page came from, but that's not required. It can send it to other websites. This one sends it to wherever you put this, it will send it off to that website. And so I've tried this, put this web page on my computer. I just double click the file. The browser opens it up, displays it. When I click on it, it sends that stuff off to the website here, which is my website, and does that, which is not where I got the file. Now, I did some experimenting with Cross Site Request Forgery about sending cookies. Some of the website says it's going to send cookies when you go off, get picture. I could not find any examples where it sent cookies when you want to access a file for the source field of an image. In other words, when you had something like this, it would go off and get the source, but it wouldn't send a cookie to that website to get it. So it doesn't show. Now, if you access a form like this, then yes, it did send a cookie with it. If you have different applications, in other words, if you have the browser open with two tabs, you can share cookies between them. Now, if you have two instances of the browser, in other words, if you have, say, Chrome or Safari or whatever it is you're using open, and you have another issue of the browser open, so you have two windows, they're separate. But if you have two tabs in the same window, they will share cookies. And of course, if you have different browsers, you have Edge and Chrome open on your site. They don't share cookies. Edge and Chrome never share cookies. They don't like each other. But if you have two web pages open in the same browser, two different tabs, which I do an awful lot, one can access the cookies of another. Also, links in emails or web pages don't always point to where they state. I mentioned this before. You can have one where the text that appears on the web page or in an email may say something nice, but the actual link where you go when you click on that need not be the same thing, warm and fuzzy. As my example here goes to spiders and snakes when it says warm and fuzzy. Now, the faculty email at A&T goes through a system that reads all my email, checks all the links, changes the links to direct the any link to go to their safety system. They have a server that checks for bad, well-known, dangerous websites. So if you click on it, it directs your request to the safety system. The safety system looks at the command, which is embedded as the information in the website. Looks at, is this a website that we know to be dangerous? If it is, it pops up a big warning message to me saying, you don't really want to go here. And usually, if it says that, I don't go there. But then, if it feels unsafe, it redirects you off to the correct website. So that's an example where using it may have value, but often if you go out here and you see one thing and it goes someplace else, you've got a problem. And I don't know if I said it earlier, because different tabs, when you are done using a website, when you have logged into your bank and you've done what you want to do, log out. You should always log out of websites when you're done. Don't just hang around. Go to some of the, don't just close the window. No, you need to log out. Because when you log out, you're telling the other site that you're done. And it will change your status. And after that, if somebody attempts a cross site request forgery on you, it won't accept it because now you're logged out. And in order to do anything else, you'd have to log back in. So, safety to all users. Whenever you are done using a website that has a log out button, use it. Always log out when you're done. Last fall, actually, I was teaching this class. The warning came out about attackers changing QR codes. They had QR codes. It's really tricky. This is a very simple attack somebody can do. A lot of times you go to a restaurant, right on the table, we'll have a QR code. So scan this to get the menu. Well, if you're Mr. Nasty and you go out there and you have a sticky label, you printed out labels with QR codes, and you can carefully push them over on top of the one that's on the table. And then when somebody comes and scans that, now you only cover the QR code, not the rest of the statement. So nobody knows it's not, humans can't read QR codes. So if somebody scans their phone with the QR code, it will not go to where the restaurant thought it would. It will go to an attacker site. The attacker site will most likely send everything that you send to it off to the website of the restaurant. So return it back to you. So you see all the information. You see exactly what you want to see, what you expect to see. So it sees the menu and you click, and then it says, well, how about paying for it? And you click yes. You enter your credit card information. Well, of course, it goes to the attacker site, which gets the credit card and forwards it off to your restaurant. So your restaurant gets paid nicely. But now the attacker site knows your credit card information. It knows your number. It knows that secret three-digit code in the back, all the other information, name, address. So it has all that information. You don't even recognize it. This could be going on for months before anybody realizes what's happening. Just by taking, you don't have to be much of a computer whiz. You just take sticky, put it out there. You do have to create a website, though, that bounces things through it and records all the information. Very much like the web proxies we use, except instead of putting it on intercept, you just capture the information, record it, and let it go through. All right, we have a question. I'm sad to say I messed up this afternoon and I forgot to put the questions out on Zoom. So everybody out there on Zoom land, I apologize. Can't click on the questions because they don't have the questions out there. But think about it. You should know what the answer is. Anybody need a card? I got a card. Another answer? Oh, that's the answer. That hold it up correctly. Oh. You always do. I don't know why you're doing. All right. We're tied. B and C are tied. And unfortunately, I apologize to online people don't know. The answer is B. It's dangerous because it can separate. Prevent it, nope, the same origin does not protect you. Same origin site only says that the JavaScript programs can only send things to the same site where the web page was loaded from. You can go any place with an image. And cookies are not sent, but that doesn't make it safe. Okay. What can you do about this? There are several frameworks. Again, when you go out to build a website, some people, crazy old computer science professors may open Notepad and type in the HTML by hand. A lot of people use some sort of framework that comes with a system that does this for you. It tries to prevent that. You can use non-cookie tokens. What is a non-cookie token? That's sending something from the HTML that is not, that's in this. You can have hidden fields in the web page that when you send something, not only does it send the information as you see, but it sends hidden information. Something just like a cookie, but it's not sent to the cookie mechanism. Header origins refer, specify the header origin in the header, the HTTP header that's sent. It specifies where did you get this information? How did you get here? Where did somebody type it in, or did you click from someplace else? And you can check on that. Same site cookie option. Oh yes, on your cookies you can specify this cookie can only be used to this same site, and your image is only in trusted email. There are a bunch of systems that will provide protection. You can do things on the server and you can do things on the website. There's OWASP, Cross Site Request Forgery Guard. There's Apache, and there's more, all sorts of things. .NET has built-in protection. Different systems. There are multiple systems that try to protect against this because this is a serious problem. Oh, and non-cookie tokens. I just mentioned this. Non-cookie tokens are things that are obviously not part of the cookie, but their information sent to the website. A lot of web pages are built by the server and then sent to the user's browser. There's a program in the server, runs, generates the web page, and sends it off to the server. It's very easy to have a web page which is mostly developed, and then a PHP program just puts a few fields in there. Maybe just changes the hidden field. And so it comes down that when you do something on the web page, when it sends information back to you, it will send that hidden field. So it's traveling as part of the URL, but it is not part of the cookie. Therefore, it's not sent as part of the cookie. Now, a web browser's JavaScript could look at that information, but it's not going to be automatically sent on an image or anything. And yes, we wouldn't put them into cookies. Yeah, as I mentioned, you can have hidden fields that send things and you don't see them on the screen. They are hidden, but they are sent back and forth between the browser and the server. I think I got ahead of myself. I just said, okay, there are options with HTTP cookies. You can have origin. It's not yeah, it appears as an option. It says, where did this come from? Sent only on a post. Tell us the website, who generated the request. Did you type it in? Did you click on a link? If you clicked on a link, it tells you what web page sent them there. And that's websites like to know where their requests are coming from, who directed me here, because that's a big part of keeping track of all the information, which is a huge business in the internet. Who is using what? Refer, same thing, refer who got you there. And if they're not the same, then you may be a issue. Oh, yes, and refer is null. If you typed it in, nobody referred it, you just did it yourself. All right, also the cross-site request forgeries and cross-site scripting. There's a lot of information on that at cheatsheetseries.owasp.org. Go look at that stuff. It gives you lots of ideas on how to protect yourself, both server and browser servers. Okay, any questions about cross-site request forgery? Then we will move on to review. But first, let's see if I can do this properly. Zoom. Okay. Oh, yes. Everybody except for people in class. There we go. People in class can now see it. Oh, I love this system. Yeah, let me see if I can do this. Okay. Hopefully everybody can see the Wikipedia page here. Yes. I use Wikipedia because it is safe. Now, it's the browser. I'm using, I'm using Chrome, although, and I want to look at the web page using the browser. In Chrome, you go Control-Shift-I, and it opens up. By the way, just backing up. Alternately, you can go up here to the options, go down to, keep going. Where is the inspect? Nope. Yes, more tools. Developer tools. Yeah. Oh, well, that was there. Same thing. And Chrome, Edge, Safari, your favorite web browsers, all the ones I've seen on Macs and Windows, all have some sort of developer system, a debugger. This is really useful if you are a web developer and you want to see what the heck is going on. You're running your JavaScript program and it's not working, and it's really nice to be able to see what is it doing. Okay, so here we are. I find clicking over here on elements, best place to start them. That shows you the yes, is that? Oh, well, okay. It's not showing me. You should use your list of things, right? And I am not getting, how about sources? Let's go to sources. That looks better. Okay, we can look at the main page here. How about watch? What if I click on watch? Yes, there we go. Watch one. Here, we're looking at document.cookie, and there it is. There's the cookie. You can, I think if you right click on this, you can say, well, copy that value. And you can copy it because sometimes you're looking at it here, it gets kind of annoying. I note that, yes, it's moved. It knows my position right now. Hey, that might be closer to A and T. Okay, kind of knows where you are. Big brother is always watching. So that's how you use the debugger in your browser, and you're still seeing the web page where it's squished over. Sometimes you can move this back and forth to get more if you want. Then you just click over here, a little X, and we're back. Okay, how about that? Yes, and then get my mouse back. There we go. All right. Stop sharing. We're back, and we'll go to the any questions about the browser debugger? It's a really useful tool. Okay. Well, for this sort of class. And we will go there. Just a second. Let me okay, share that website. All right. Okay, but here we are back. And review for exam 2. That's because we'll get this to work yet. Okay. The second exam in this class is on Monday, October 14th. That's next usual class period. There will be no class on the day of the exam. You get to spend 18 hours working on the exam, although it shouldn't take you 18 hours. Again, it should only take you a couple hours, an hour and a half. It'd be nice if it took an hour and 15 minutes, which is the time of the class. It may take about 2 hours. So don't wait till 11:30 to start it. It will stop you at midnight. It's online for everybody, including these people sitting here in front of me. Nope, the exam is online, just like last time. Open book, open notes, open web, probably open AI. And I can warn you that I have run all the questions through a couple AI systems. And if I get a good answer from the AI system, well, then I don't give you the question. So using logic, you can say that if the question appears in the exam, then the AI system does not give a good answer, which should be a warning to you. Okay. Keep the answers down to 75 words or less, please. I do take off. The TAs have been told to take off points if you get really long answers. Some people go out to AI systems. They get a nice, page and a half, and they copy and paste it into Blackboard. We don't want to read that thing. Copy and paste it into another AI system, tell it to summarize it to 75 words or less, and then put it out there. It might be wrong, but at least it'll be 75 words or less. You won't lose those points. Okay. Some of the questions ask for your university ID. When I talk about your university ID, I mean the banner ID, the one that starts with 950 and then another 6 digits. If you have an A&T 1 card, that's a different number. I want the banner ID. When I was grading the last assignment, the one that was due yesterday at noon, there were a lot of students who gave me the last 4 digits of the ID number, but they were not students in the class. I mean, there were people in the class who didn't take the quiz, and then there were people who took the quiz who weren't in class. So why don't you go out there and put a number around the class? So I suspect some people used the wrong number. So if you look out at Blackboard and you got a 0 for the assignment or something that you didn't expect, then let me know. This would be the SQL injection portion of the quiz. If you got all the other parts correct, you should know that you went out to the dark web website and you probably got 60 points. A lot of people got the 60 points for that part of it. Then there was 40 points, 2 20-point questions for the other ones. If you got 60 points, you thought you got those correct, let me know. Some people use the wrong number. We'll try to get that corrected. Take all points for not knowing your ID. Yes, we have a question. Excuse me?
Is the grade for the SQL injection count?
I have a total. I have a sum. It used to be 60 points. It's now up to 100 points. I added in what everybody got. And so you've got a score between 0 and 100. And yes, there were a lot of hundreds. People did pretty well in the quiz. If you suddenly think, well, I didn't get all the points I should have gotten, let me know. Send me an email, and we will discuss numbers and figure out if you used the wrong number. And if so, I have half a dozen numbers that got pretty good scores, but I don't have students to connect them to. So on the exam, just in case you happen to see a assignment that asks you to use the last 4 digits of your ID number, use your real ID number. Yes, you have a question? Okay. Yeah, some people made mistakes. All right. Okay, these are the topics that we've discussed since the last exam. There will be no questions on the exam from material covered previous to the first exam, unless for some reason it's intricately tied with some of these topics. These are the topics we've talked about since the first exam. There will be no questions about topics covered in the textbook reading that we did not cover in class. So all this material that we cover in class, you can go out and look at the slides, look at all, sit down and rewatch every video. Oh my gosh. And if you can live through that, then you should know all this sort of stuff. Okay. So let's go out. Okay. Just real quick review of some material. Central bank digital currency, CBDC. That's governments that make that. Bitcoin is not a central bank digital currency. There are a couple countries now that are moving into digital currency so that they have something. I hate to use Bitcoin as an example, but you can imagine if El Salvador has Bitcoin as its currency. It's not a central bank currency because El Salvador doesn't control it. It just runs wild. But it is very possible for a country to make a digital currency and then use that. There are several benefits. You don't have to use the credit card companies. Yes, the Department of Justice sued, I think it was Visa, for their exorbitant charges on debit cards. It didn't say anything about credit cards, just debit cards. Last year, they made $6 billion on debit card charges. I might point out that credit card and debit card charges are usually a major expense for small business owners. If you have a small business, you go and buy a cup of coffee and you pay for it with your credit card, there's 3 or something percent charge to that, which your vendor pays. They often pay more money to the credit card company than they pay to their employees. So it's a major expense. I don't know if it's a rash. I am not going to make the judgment as whether it's too much, but $6 billion seems like a lot of money to me. And so they're pulling $6 billion. If the government ran it, then they wouldn't charge. But then again, yes, I'm from the government and I'm here to help you. Yes. Okay, again, greater access to the financial system. Many of the currencies say don't require a central bank. They are distributed, so you don't require a bank. Anybody can do it. Economic growth. And also, a big purpose for the governments to do it is they send money, governments and major banks send money to other countries. Particularly, big banks send, the big investment banks send money to other big investment banks, either in the country, and therefore it would be very easy for them to use some sort of central bank system. Now, the concerns, stability of the financial system. As I've mentioned earlier, Bitcoin is not in any way stable. Neither is Ethereum or some of the others. Some of them have crashed and gone to nowhere. Hopefully, a country could avoid that. And of course, there's also the question about sensitive data and control. There is a movement by some representatives to prevent the government from ever creating a central bank digital currency because they're concerned about privacy issues, that the government would know everything. Of course, second goal is avoid, if you built this, if a government was going to build it, you wouldn't do it like Bitcoin because Bitcoin requires vast quantities of computation using lots of electricity and heating, cooling. And yes, these Bitcoin mines use a tremendous amount of electricity. They are a measurable percent of all the electricity used in the world. I think we showed earlier that Bitcoin mining uses more electricity than the country of Argentina or the country of Sweden. I mean, more than every person in Sweden combined. It's a lot of electricity. And obviously that has impacts on the environment. You want it to have good customer experience, of course, and you want it to be safe, work just like cash. Okay, that's SQL injection. You don't need to know SQL for this class. They're not going to ask you to write an SQL statement. All you need to know is the dirty tricks of what you can put in here. Typically, you want to attack the last statement. Now, of course, there's no reason why you couldn't say select star from login where password equals this and user ID equals that one. But most people think user ID and password, so they put it in that order. So you're going to put something into the field where it says enter your password. Instead of entering a password, you're going to enter X, quote, or, quote, A, quote, equals, quote, A, no ending quote, no beginning quote, always an even number of quotes. And then this goes in there and it changes this. So it looks like this statement here. User ID equals Alice, assume we type Alice, and password equals X, or A equals A. Well, A is always equal to A. That's a true statement. And in logic, if you have A or B, if either one is true, then the whole statement is true. So if A is true, it doesn't matter if password equals X, it's going to be true. So it's going to be true. It's going to go out there and find the statement where user ID is Alice, and it'll return a record to the system on the server. And the system goes, oh, I've got a record. I asked for is there a line in the database where it has the correct username and the correct password? It returns something, so it must be correct, when in fact, it's not. This comes from, why I talk about that? It comes from concatenating things together. Never, ever do that. Okay, numerical, when you do numerical, you don't have to have the quotes. You have numerical because numerical values, if they appear in an SQL statement, SQL knows that that is a number. It's a constant. Numbers are constants, so it doesn't have to put a quotes. All data, their names in a SQL statement have to be inside quotes. But if it's a number, oh, that's a number, I don't need that. So if you just said, we're doing a PIN, say we're looking for a login, like you got a bank, you type in your PIN, it goes out and it says, oh, put the username in there and the PIN comes out to be if PIN equals 1 or 2 equals 2. Well, of course, 2 does equal 2. And so this statement is true. And so it's going to return a record. And so the program that runs this is going to go, oh, I asked for the user ID and the matching PIN. It returns something, it must exist. In SQL, anything after 2 dashes, a double dash, is a comment, and everything ignores it. And in general, SQL statements end in a semicolon, although most SQL systems are very loose about that semicolon, and they run perfectly well without it. I mean, if you're running a Java program or a C++ program, you don't have the semicolon, it's an error. Not so in SQL, it just lets it go. So you can do things like put something in here and then put a semicolon dash dash. The semicolon ends the SQL statement, and the dash dash says, oh, ignore everything that comes after this. So you put this in here, and it comes up. We're going to go select from my table. Again, my table is the name of the table, where user equals this, or 1 equals 1. Well, we ask them a user. Well, it doesn't matter because 1 equals 1 is always true. That's going to be true. Semicolon dash dash, that ends the statement. Everything after this, the and password, that's going to ignore that, doesn't care. It's a comment. Comment values are ignored. So, what do I do about this? Remember that if you're asked to do this, punctuation is important. Got to get those quotes, always an even number of quotes. Numbers are not surrounded by quotes. How do you prevent this? Well, you want to sanitize your input. If you don't need quotes or equal signs or other funny characters, then don't allow them on the input. Now, frequently you'll see statements where your password has to have letters, numbers, upper and lower case, and any one of these funny characters. Often the list of funny characters does not include things like quotes, less than signs, greater than signs. It only does things like multiply and maybe dollar signs and things like that. I have an automatic password generator, and one of the features is use the common characters or use every character, or avoid characters that humans can't tell the difference between. Steganography, another topic that we covered. Steganography is the art of hiding information. Encryption, you can encrypt information and somebody can see the information, but they can't read it because they don't have the key. And again, any good encryption system assumes that the attacker knows the algorithm, knows what you're doing, but doesn't have the key. An encryption system should not allow them to view the information if they do not have the key. Steganography says you're not even going to know the information's out there. You're going to try to hide it. And there are multiple ways to hide it here and there. A very common way was to put it in the least significant digits or least significant bits of a picture. Picture has often 24 bits to describe the image, or each little pixel has a 24-bit number telling you what color it is, how bright it is. Well, if you change the least significant bit on one of those values, you're not going to notice. The human eye doesn't really easily detect the difference between this color and a color that's almost like it. So you don't detect it, but then you can write a program that goes out there, picks up the last bit of all the bytes in the file and strings them together, and that makes the message. I have done that in the past, by the way. In the past, when everybody in the class could program, that was an assignment. Write a program that strung the bits together, hit it out there, and then pulled it out. But we're not going to do that. This is security through obscurity. That means you're trusting that nobody knows that you hit it. That's not a reliable security system. But things have been out there for a long time. And again, you can do it in documents, HTML document. You can have hidden text in a Word document. I don't see it. It's out there. Put comments on HTML. HTML comments, put your data in HTML comments. It's there in the web page, but unless somebody looks at the browser source, they're not going to see it. Okay, and how do you avoid that? there's content threat removal. It's a system that goes out there. One of the things it does is it recreates the image and then looks at it. Instead of taking the actual file, it takes a copy of the image of the file. And you can put these things and look at the information. There's also statistical analysis of the bits. Usually, again, they're using the least significant bit, which should follow some statistical pattern in the file. If you have a blue sky and you have lots of pictures of the blue sky, then bits are pretty much just, or follow a pattern. If you have a hidden message, the bits will appear somewhat random in the last bit. Okay, network stuff. How do you map between networks? Again, there are three addresses for a computer. You have the MAC address. The MAC address is the hardware device address built into an Ethernet. Every laptop, every Ethernet card has a separate number built into it. It's usually a 48-bit number. But humans don't want to remember 48-bit hexadecimal numbers, so they use, and that only works on your network. It doesn't work on somebody else's network, which, by the way, may have a different hardware type. They may not use Ethernet. They may have token ring or any one of the other many network types out there. It doesn't matter, because you're going to send things over the internet using internet addresses, which are 32-bit, or if you're using Internet Protocol version 6, 128-bit. And then, but humans don't like numbers, so humans use names like acme.com, and then a domain name server computes between, or go out there and you send it a request, say, what is the internet address for www.acme.com? It sends you back 32-bit address or 128-bit Internet Protocol version 6 address, whatever you like. And then if you need to send it on your network, you need to use the hardware address, because that's the only address that the hardware will recognize. Then you have to map between hardware addresses and internet addresses. And that's done by the ARP protocol. There is an attack called ARP poisoning. It simply says when a system sends out a request for an ARP, for an address with ARP saying, who is this IP address? The machine who owns that IP address is supposed to send back a request. Say, here is my MAC address or hardware address. Well, what if the system replies, isn't that machine? You can send back a false reply saying, oh, I'm that address, when you aren't. And then the victim computer will send everything to that address of the attacker. There are multiple corrections you can, again, for important things like your router that goes off your network, you can go out and get an accurate value, and then don't allow that to be changed. Put it as a read-only value in your ARP cache. The ARP cache, all the computers have a small list of addresses that they know, ones they've already looked up. Whenever you look up an address, you save it so you don't have to look it up again. And you can have some items that are read-only. Usually, if you go out to command mode, terminal mode in the Mac, command mode in the Windows, and type ARP, you'll get information, you get the list. And you can also enter read-only values. MAC address, DHCP, Dynamic Host Configuration Protocol, that starts up, the computer starts up, goes out and asks the DHCP server, what is my IP address supposed to be? What is my name supposed to be? And it will send that to it. So it knows everybody's addresses. You can ask it. And then IP version 6 tries to correct this problem. It realized that there was a problem in IP4. IP version 6 tried to fix a lot of the IP version 4 problems. And it has the secure network discovery protocol. And that uses encryption, digital signatures to securely send the information across. There can be attacks against domain name servers. If you send information to domain name server saying, I've got this information, it can be wrong, it can be sending thing, the domain name server will send the wrong information out to users who request it. There are security extensions that domain name security extensions or DNSSEC updates you can put in there, and that uses, again, encryption, digital signatures. So when a site sends its address to it, it knows that it's coming from the correct site. Okay. Cross site scripting, which everybody should have some idea about. Here's your simple website where you send something and it goes, sends the parameter in the website. Again, websites have the site name. Question mark separates the address and parameters, and the parameters then are name value pairs. User is the name in the web page, and Ken is the value that it got. And then it may reflect this back on a website, either back to you or perhaps to another user. If you're on a social media site and you want to send it, you'll send that name that it got back to the other site. It just puts it in the page. Now, if you didn't type in your name, you could have typed in something like this. Again, I use alert because alert's safe. We can do that in class. Nobody gets hurt. Send that information. It displays this. You could also do other information. You could specify images that was do cross site request forgeries and send things to other sites. So of course, this gets displayed. When this gets displayed back, instead of showing your name, it will pop up the message. So how to fix this? In your HTML input fields, you can specify patterns or requirements for that HTML field. And then if the input doesn't match that pattern, a pattern can be, it has to be a number. Oh, or simple things you can like numbers, email addresses, web page URLs. And if it doesn't matter that pattern, then it won't accept it. You'll get a little error message on your browser, and it won't get that information. So this is really useful in catching errors and stuff. And not only can you do the built-in ones like URLs, email address, numbers, that sort of stuff, you can specify a pattern. Those of you who took the theory class in computer science and wondered, why did you need to know about recursive regular expressions? Aha, regular expressions do show up. They are useful. There's a reason why you have to do that sort of stuff. Okay, cross-site scripting. There are two flavors of cross-site scripting. Non-persistent is the reflected. That means you send it out and it comes back. You might put it in an email and convince the user to click on the email link. It goes out there and sends the information. And I pick up stuff from your site and sends it off to that one. And it doesn't save it anywhere. It's just kind of a one-time use. Then there are persistent ones. These are more dangerous because here you're going to store that attack information. A very common way to think about this is imagine you're going out to a social media site, and instead of entering the kind of data that it expects, you enter a cross-site scripting attack. And so when it shows that cross-site scripting attack on some other user's web page, it will then execute that JavaScript, which can do whatever you want the JavaScript to do. Now, our examples have been pretty short, but often you can put along with it. Yes, question. Yes, and that would impact everybody who looks at that information, which could be an awful lot of people. I mean, if you're an attacker, this is the way to go. You're not going to get just one user. You can get lots of people, lots of victims to do this. And in earlier versions of all your favorite social media sites, that used to happen. Now the social media sites are much more aware of these dangers, and they've tried to prevent them. Proxies, network proxy. Yes, we use the Burp Suite network proxy. It could be a network proxy, could either be hardware or software. Let's imagine the software version like we use. It's just a program that runs in your system. And everything that's sent to the network, instead of going directly to the network, goes to that program. It sends the data as it appears as network packets. Instead of sending it actually, it sends it to the network proxy, the HTTP proxy, which then can look at it as in Burp. You can look at it, and if you wish, forward it along. You can also edit it. One of the nice features of the proxy is it allows you to edit the fields and change values. So you can go out there, send information on. That might be really useful if you needed to get a score better than 100. And then it sends it out. And of course, it works both ways. Information coming back from the web server goes to the web proxy. And in the way we're using Burp Suite, it wasn't capturing that data, but it is possible to capture the return data before it appears in the browser. You can view it and again, edit it if you are so inclined. Parameter modification is yet another attack method. some websites have parameters that they probably should not include. In this example here, we have a bookstore showing that, and it's going to send the information out, tells what book they want about the ID. You know, there might be a number associated with this book. Quantity one, they picked up the quantity, and the price. They're going to send the price. Well, that's going to make a request that looks like this. It's going to send it off to books, and it's going to have the ID, the quantity, and the price. If you had a web proxy and you stopped this, the intercept on, you stopped it, you didn't like $59.95. Maybe I just took the 9 out and did it for $5.95. That'd be a lot nicer on my budget. I could get that book for a lot less. Well, somebody said do 0. I wouldn't do 0 because 0 might cause something might notice 0. In other words, the system might go 0, there's something wrong, error. If you put $1, they're like, oh, it's money, it's something non-zero. You can put a penny, I guess. Yeah, if you're really sneaky, you don't want to put something that will cause problems. 0 may cause problems. It's going to appear in your bank statement, their bank statement, or they're going to go, $5.95. Yeah, you paid for it. I got it right there. I paid for it. And then they got to prove that you paid the wrong number. That's going to be hard for them to do. Yes, it said $5.95. Bank paid $5.95, didn't it? I got it. Got the book. Okay. So yeah. So the answer is don't do it. Don't put that information out there. Basically, you should the book ID, the quantity, and you know who it's coming. You know what book it is. You should know what price is being offered. Now, you might have some code out here indicating, does this user pay the full price? Do they get a discount? And that might be there. It might be in the cookie. And then you can use that, look in your database to see what this is. In fact, your database should have information about the user, information about the book, and you can decide on the server, what is the book price? Don't put information out where users can modify it if you don't want them to modify it, even if you think. Sometimes people have what looks like a really secure web page. Their HTML checks for all sorts of errors, and they send it off, but little they know that somewhere in between, somebody's going to change it. Just like the SQL injection. Well, okay, you might have a web page that tries to scan for that information, but somebody's proxy could stop it. Oh, put the information the way they want it and send it on. And of course, watch out for sequential numbers. Your order number, we have 2457. I wonder what order 2456 was. If I put it there, will I see it? Maybe if it's not even my order. Again, order number should be related to that customer. Or another thing you do is make big random numbers. Have a random number generator that you cycle through. So make sure you don't reuse numbers. Make another number and put the big number out there so nobody's going to be able to guess what the next random number is. Hidden parameters. You can put hidden parameters out there when you have a input field that has input. You can also, in addition to the input that the user types in, you can have hidden fields. Hidden fields aren't displayed to the user, but when you press submit, it sends it off to the server. And as a web developer, you go, well, nobody saw that. It's hidden, right? Well, yes, it's hidden, but it's not hidden from the HTTP proxy, which could see it and modify it as it wants to. Clickjacking. We talked about clickjacking. That's where you use the iframe feature in HTML to put a different web page in your web page in a box. Usually they make the box full size, so that web page appears in your web page, but you'll overlay your information on top of it. So you can put an absolute. So you look at the victim web page that you want, and you find, oh, here's a field that's interesting that I want to capture. And it's got this location. You make another web page that overlays that. Oh, let's look at this. So somebody goes, oh, there's an interesting field. So I make my web page, and right on top of that, but I put something else. So when they were going to click go, instead they're going to click there, and it's picked up by my website. Whoops. If you go out to the class website, 422.com620.online, there is an example of clickjacking. I'm attacking the acme.com website. I have nothing against acme.com. We're not doing anything dangerous. But if you click on where it says Acme Update, normally, if you just go out to the website, you click on Acme Update, you see the latest changes to what's happening out in Acme. But if you go there through the link that's on my website, you'll see the web page, but when you click on Acme Update, you will not go. In fact, I think it puts you to the Alice and Bob pages on my website. And of course, that's not doing any damage, but it could. All right. I haven't written the whole exam yet. I'm still working on it. TAs and I are busy writing it. But if I were you, I would be sure that you can do SQL injection, clickjacking, parameter tampering before Monday. Again, Monday, October 14th is the exam. Like the previous exam, it'll be online, opens up at 6 a.m. on Blackboard, runs until midnight. Don't wait till 11:30 to start it, because at midnight, it's going to turn into a pumpkin and it's going to close it. Open book, open notes, open AI. But be careful about that AI. I have run all the questions through AI systems. If AI gave me a good answer, I didn't put it on the test, which should give you a hint. Answers cannot be more than 75 words. I don't want to spend all our time reading lengthy answers. Keep it short. 75 words is a pretty good sized paragraph. Okay. There's a number of conversion quiz requirement to get a score over 100. Got to have that. There's a couple ways to do that. I think I mentioned 2 different ways today. That's due on Sunday at noon. It's out there on that website. You can use the debugger or HTTP proxy. You just have to change the value, and so that you get a score that's better than 100. Several people have already done that. You don't have to upload anything to Blackboard. The server it asks for your last 4 digits, your ID number. Use your real ID number again. Use the ID number that the university gave you. It starts with 950 and some others. Use the last 4 digits. Question. Does it ask for your name? Okay, good. Use your real name. Don't just say Fred. You gotta say like Fred Smith, so I know who you are. There's maybe more than one Fred in the class. Yes, please, and use the name that the university knows you, because I'm going to match this up to my list of students. And I got the list of students from the registrar, and so please use the name that the registrar knows. Yes, we have a question. Just your first name. Just put out Fred. Yes, you do. But yeah, I might recognize you, but it makes life so much easier if you just put your name out there. Yes, people who have names that are not common in America, then they're pretty. I will know who you are. If I can possibly match you up, I will do so. But it's easier if you just use your full name. Then I know who you are. There's no question who you are. I mean, you can use somebody else's name if you want to, but then they get credit, not you. But don't. That would be cheating. Yes, remember, you are allowed to look at the web. You're allowed to look at your notes. You go out and review the recordings on YouTube. What you can't do, which is considered cheating, is if you ask somebody else, particularly somebody else in the class. If you say, "Oh, what did you get for question 5?" That's not fair. It's an individual test. You have to do it yourself. Okay. Again, that is on Monday. We are doing it on this Monday. This is the second of 3 exams in the class. The last exam is sometimes after Thanksgiving. This may seem a little early. It's not like 2/3 the way through the course. That's because if you've been counting, we've had 13 lectures. There are 24 lectures total. And so this is hardly halfway through. But a week from the exam is the last day to drop. And so you do the exam, gives the TAs and I a chance to grade it. We'll try to, it's our goal, if we can, we want to grade it by 4:30 Wednesday on October 16th. That might not happen. There are a 97 students in the class. It's a lot of grading. We'll grade it as fast as we can. Sometimes issues come up. TAs and I have to discuss what to do about that, come up with it slows us down. We'll try to get back definitely back for the end of the week. So you will see, I will send everybody an email, personalized email to you, giving you score of the exam along with a summary of the scores that you have for the class and what is your letter grade so far. You could then use that information to decide. In other words, if I send you the score, the summary, and your letter grade is a D or an F, well, D is pretty bad if you're a grad student, then it may be time to bail out. On the other hand, you get an A, maybe a B plus, stay around, keep working at it. And if you think you can keep going, do that. So I'll send you that summary of your grades sometime before Monday, because Monday at 5 o'clock is the last time the registrar will allow you to drop a class. Question, okay, that's it. Do we have any questions about the upcoming exam or anything that might be on the exam? None? Nobody online? Huh, well then we're done, 10 minutes early. Well, 9 minutes early. Okay, good luck on this exam and all exams. If you have questions during the week, send me an email, send me a text. Let me know and we'll do the best we can to answer it.